So today we're going to talk about vectors and scalars. All properties we measure can be broken up into two categories, either scalars or vectors. So scalars are properties that do not depend on direction. So every scalar consists of a magnitude, but no direction. And a magnitude, we should remember, is how large a value is. So the magnitude tells us if a number is big or small, but direction has no role in the magnitude. So let's think of some examples of scalars. Speed and distance is the first example that we've used. Suppose a man were to walk 5 meters, turn, walk 5 meters, turn again, walk 5 meters and turn again. He would have traveled a distance of 20 meters. If one man were to walk 20 meters in a straight line, his distance would still be 20 meters. So even though they may have changed direction, we're only concerned with the fact that the distance they traveled is 20 meters. Time is another example of a scalar. Notice how there's no direction that we associate with time, and whenever we ask for a measurement, we only give the magnitude. Right? We only give a value and not a direction. Temperature is also an example of a measurement that doesn't depend on direction. All we care about is the value. Vectors are properties that do depend on direction. So every vector consists of a magnitude and a direction. Because vectors consist of a magnitude and direction, we can represent them with arrows. Each arrow has a length, and the length represents the magnitude of the vector. Each arrow is pointing in a direction. So the direction the arrowhead points tells us the direction of the vector. So examples of vectors include velocity, acceleration, and forces. Those are the three examples of vectors that we've covered this year. So the first example we're going to look at is velocity. Here we have an example of an object that's traveling at a constant velocity, an increasing velocity, and a decreasing velocity. So we should ask ourselves right now, how would the vectors look different on each of these different scenarios? While you're watching the scenarios, keep track of how the arrows are changing between an object that's moving at a constant velocity and a non-constant velocity. Next example will be acceleration. The last example is forces. Again, focus on what the vector arrows are telling us. Are they changing? What does that mean? Are they staying the same? Which direction do they point? Does this make sense? These are questions you should ask yourself. Vector components. The direction the arrow points tells us the direction of the vector, whether it be vertical, up and down, or horizontal, left and right. If we have a vector that points off at an angle, part of that vector is in the horizontal direction and part of it is in the vertical direction. The horizontal and vertical part of a vector at an angle are called components, and they help us describe the direction of a vector. The red below shows the horizontal component, and it tells us how much of the original vector is directed horizontally. The blue shows the vertical component. It tells us how much of the original vector is directed vertically. Adding vectors. When we combine two or more vectors, we call that adding vectors. So if we take the lengths of those vectors and add them together, we should get the length of our new vector. This becomes a little bit more complicated when we have forces at an angle. We add vectors by taking the tail of one and placing it on the tip of the other. Then we draw the resultant vector by connecting the tail of our first vector with the tip of our second vector. The resultant is the sum of the vector addition. It combines both the magnitude and direction of each individual vector we add. So to summarize, to add vectors, we draw them so the tail of one is touching the tip of the other. Then we draw the resultant by connecting the tail of the first to the tip of the last vector drawn. So first I'll draw my vector, Then I'll draw my second vector, so the tip of vector 1 touches the tail of vector 2. Finally, I draw the resultant vector from the tail of the first vector to the tip of the last vector. Whenever we have more than one vector, we can add them to get a resultant vector. This resultant tells us the combined direction and magnitude of the others.